Hello everyone, I want to make a quick tutorial about the particle editor. There's been a lot of confusion about it and very little to no documentation about it. So I quickly wanted to just talk about it, how to use it, and how to create your own particles with it. I'm already going to assume that you know what a particle system is, considering you already want to make your own, but in case you don't know, they're basically just spawners of two-dimensional objects in the three-dimensional world. You use them for things like fire, ambience, weather, and all that stuff. I'll first make a quick understanding of the editor before going into the more advanced stuff. I've set up a pretty simple scene here, but as you can already tell, there's something missing. So of course, because some pretty cold looking area, you want some form of snowfall, which is what we'll be creating here today. So first off, how do you even get to the particle editor? Under the Windows menu, there is a button for the particle editor tool. Once you click that, your entire SFM changes into this really ugly looking mode. If you want to go back to the normal SFM, you just go to Tools, switch to SFM. So first off, you should understand how particle files are actually stored. There's something called a PCF file, which you've most likely already known of when you used SFM with particles. Here's a list of them in TF2. Each PCF file contains a number of particles inside of them, and the reason that they got separated like this is due to efficiency reasons. You don't want to load all the particles in the entire game if you just use a single one of them. For this tutorial, we'll be creating a new PCF file and put all of them inside here. So, in order to create a new particle, you have to press the create button on this top left menu. You then have to give it a name. We'll just call it snowfall. This is also the name that will later show up when you're picking the particle inside SFM. So you can now resize this to how you want it. Down in the bottom right here, you'll have a preview of the particle, the way it will look like in the game. The engine viewport up here is totally useless, so you can just ignore that. Of course, up here you have all the particle system definitions inside your PCF file in a list. And this one is the most important bit. It's the properties of the particle. Here you can see a number of options on changing the particle. First off, we'll be saving this PCF file. So we go to Save As, give it a name. Then you may think this is crashed at this point, but it just takes a while to save PCF files. After this is done, it'll ask you to add the file to Perforce. Whenever a message like this comes up, you should just press no, otherwise there'll be an error. It'll save it nonetheless, but still it's something that you shouldn't be caring about. So, you might be overwhelmed with all the options here, but I'll just be going through the most important ones and explain all the stuff that's going on here. First off, on the very left here, you'll have different categories. At the top, there's system properties, and then you go down to renderer, operator, initializer, emitter, and so on. The system properties are all the properties about the particle that do not change. These are all stationary. The most important one to note here is the material, because that's only available here, as you cannot change the material over the lifetime of a particle. So once you press the ... button, a familiar material browser should come up. Not every texture will work with particles, as you might be able to tell from this preview here. Most will just appear gray. To find something that will work, just search for particle or effects. Most of them will then actually show up. As we want to make a snowfall, there's a pretty nice texture called SC Soft Glow Translucent, which has this sort of crunchy effect to it, which I really like using for snowfall. So since what we'll be creating is a natural effect, we actually don't want to use most of these properties in the system properties here, because they are not randomized, so things like lifetime, size of the particle and all that is something that we'll be later randomizing. The only thing that is still of note in this menu for us is the max particles, which changes how many particles you can in total have. we'll always be changing this to 5000 because there's no point in limiting it further. Of course, if you have a slow computer, then you should of course set it to a lower number, but 5000 is the maximum that you can set it to, so I'll be using that. Now we'll be going through the subgroups that we have in here below system properties, because they'll be the most important things to work with. So first off we have renderer. Renderer should already be obvious. It's going to decide how the particle will be rendered, what it should look like. Should it be a sprite, or a trail, or a model? All these things are included in here. Then we get down to the operator. The operator may not be as logical at first. It's basically everything that gets decided during the lifetime of a particle. How it moves, if it rotates, if it changes size or color, all these things get decided in here. The initializer, on the other hand, is what gets decided when the particle gets spawned. It changes where it spawns, how big it spawns, in what color it spawns, and all these things. The emitter is obviously how the particle gets spawned. Does it just spawn in bursts? Does it spawn continuously? How fast does it spawn? All these things. Children, they're a little more complicated. If you have another particle definition up here, you can have this particle combined with another. That's just so you don't have to put 6 different particles down in the same spot. You can instead have them all connected to each other, and they can even interact with each other. So you can, for example, have each of the snowflakes from this snowfall have a trail, for example. So now we get to the less used ones. So first off we have force generator. Now force generator is a bit of a weird one. In operator you can decide how a particle moves, but you can also do that in force generator to some extent. It has more detailed ways to move the particles, but I don't really know why they've split it off like this. And we last have constraint, which it basically allows you for collision as well as constraining the particles in the distance it can travel. It's pretty useful for efficiency, but also of course so that you don't have the particles clipping through terrain or objects. So let's get started. First off, I'll be using the word attribute a lot. An attribute is just basically something that I'll be adding to a subgroup that will modify the particle in some way. So in order to add an attribute to any of the subgroups, you just right click the subgroup and go to add. And in here you have all the attributes listed for that subgroup. So for the renderer, there is a lot of them, but we'll only be using a few of those at all. So the most important ones will be render models, which will be used for 3-dimensional rendering of anything. Animated sprites. This includes also sprites that don't have an animation, but it's just a 2-dimensional object in a 3D world. Sprite trail is similar to animated sprites, except movement affects the way the sprite looks. And the last one that I commonly use is render rope, which obviously gets used for rope a lot and cables, but you can also use it for electricity. You can for example see that for terawatt and kilowatt unusual effects in TF2, those use render rope. Anyway, I'll be using animated sprites. So, if you look at the 3D view, there's nothing being spawned. And that is because the particle count, as you can tell, is currently 0. So we need an emitter to spawn something, so let's create that. So you have 4 choices here. The ones that I most commonly use are emit continuously and instantaneously. Both of those should be self-explanatory, so there's no point in really going into further detail. So now you can actually see something. It's a white dot, and the reason it looks this weirdly and not as we have picked it before is because it's spawning an enormous amount of them inside each other. So we of course want to first randomize where it spawns them, so let's do that. To do so, you first have to decide, okay, what is it? Is it an operator or an initializer? Well, since we decide where it spawns before it even spawns, like, it's nothing that we decide during the lifetime, but something that we decide before it. So that's why it's an initializer. So we'll be selecting position within sphere random, because it's much easier to use and has more options than within box random. I prefer using that one over the others. So here we have a lot of options. First thing that I would like to point out is that every attribute has this pile of attributes that start with operator. Those can be safely ignored. There's something pretty advanced that not even I use most of the time. They basically allow you to fade in and out attributes over time, which is not very useful in my opinion. Oh, and by the way, the camera controls for this are just left click to rotate around and right click to zoom in and out. And you can use middle click to pan, but that's not very useful. So, I'll first off, of course, be changing the distance max, which will change the radius of the sphere that the particles will be spawning in. This is measured in hammer units, and you just have to experiment around with the sizes of those. You can imagine, like, the best reference I can really give you is that the player is about 80 hammer units tall, and a wall is about 128 to 256 units tall. It really depends on the game and on the map, of course, but it should help you give some form of scale. So I'll just be using 300 here. So now we see that the particles aren't actually just spawning in the same place, they're spawning all over the place here. Still doesn't look how we want it, of course, but it's the beginning. So we of course don't want the particles to spawn this high up, because if they do, they'll be dead before they even reach the ground, basically. And that's just a waste. We'll be getting less particles. So we want to change the distance depth bias, and that basically works like you have an X, Y, and Z axis here, all signified by a 1 at the moment, and the smaller the value is, the less likely it is to go further from the center of that axis. So basically, if we change this value to something smaller, the Z value, particles will be less likely to go up and down like this. I could use 0, but then there won't be any height variance at all, which would also look weird, I'd say. So this is fine, the way it is, I would say. There's speed stuff down here, but we'll be getting into that later. So, if you know how scale works in this, you might be able to tell that the snow particles are way too big. So that's also something we'll be changing. Again, this is something that will change from the spawning and not something over the lifetime, so that's also something we'll change as an initializer. So the size of a particle is called the radius, which is why in this list we'll be using radius random. And you can already tell that the size of the particles changed, and that is because the default down here is 1. So I'll most likely be using a size between 1 and 2. Since this is a float, you can also use comma numbers, so I can actually go a little smaller if I wanted to, go a little more detailed, but that doesn't really matter. So, why don't we give them some movement, because as of now, they look pretty bad. So, movement of course will be an operator, because it's nothing that just stays, something that only gets decided when they spawn. This is something that you should think about all the time when you're searching for a specific attribute. Just when do you have to use it? When do you have to decide what you want to do? Is it when you spawn the particle, or is it during the lifetime of it? So, movement basic allows particles to move around. This is something that you always have to have if you want a moving particle. Without this, they'll not work at all, like movement will not do anything. So this is something mandatory for every particle, I'd say. Other than the, of course, the functionality to move, you have drag and gravity. Gravity should be self-explanatory. It drags the particles down a specific direction once they start spawning. Um, so, of course, the z-axis for down is what we want to change, and let's change it to, I don't know, we'll have to mess around what looks good. And now this already starts to look a little more like snow. So this is, maybe we want a blizzard instead of just a light snowfall, so we can change this value to be a bit higher, of course. We can later randomize the speed as well, using the different attributes. And drag, this is something that we'll not be using here, but I can still demonstrate it. It slows down a particle over its lifetime. So you can see that already a drag of 0.2 makes them far slower. And if we go too high, they actually stop completely at some point. So this is something that you'll be using rarely. It's more for something, well, not affected by physics. So, now we can go wild with this. This is already pretty suitable for snow. Like, if you look at it from this angle, it already looks pretty nice. But we want to change more about this, of course. So, first off, this just pops in and then falls down infinitely, which is both looks ugly when you see it spawn, and it also is performance-wise pretty bad when it spawns this many particles. So let's fix both of those problems, which with a nice operator called alpha fade and decay. This is also one that you'll be using for practically every particle that you have. It fades a particle in when it starts spawning, and it kills it once its lifetime is over. So you can tell that they die pretty quickly here, and that's because the default lifetime by the system properties is set to 1. You'll also note that they don't even fade in, they just pop in still. That is because the start alpha, which is the alpha value when a particle spawns, is set to 1. So if we set this to 0, they'll actually fade in and out, which looks far nicer. You can also change how fast they fade in and out and when in their lifetime. In this case, 1 is the end of their lifetime and 0 is the start of it, so that's something you should keep in mind. And it just fades at the moment. Half the lifetime is fading and the other half is fading out. So that's what I keep most of the time. May look ugly at times, so you can change it if you want to. Now we want to change the lifetime, of course, to be a bit longer, so this is also something that we want to decide once the particle spawns. Lifetime random, it's called. And they're not spawning at all because the default lifetime is set to 0, obviously. So we'll change this to, I don't know, 5 to 7 maybe. It's really all about messing around. I'm just doing a tutorial particle here, really. So this looks far nicer already. I must say, when it fades in up here, it does look really nice. So, some other things that we can now do. I left this out at first. At the position within sphere, we have speed variables here. Speed min and max are random directions, while local coordinate system allows you to actually pick a direction for when they spawn. We can check if this looks nice. If not, we can just use the local coordinate stuff. So this is just added on top of the movement basic. This is starting velocity. Okay, so this didn't do very much. Yeah, this is already pretty nice. So now it spreads out far more. They actually come down at different speeds too. I don't know how easy it is to tell on the recording, honestly, but it does look pretty varied already. If you want to go even more wild, there's a lot more initializers to pick from, like giving them a color so they don't all just spawn white, but we can actually pick some sort of cyan colors to pick from, which you'll again not notice very easily. But it does look nice. We can also make them spawn at different alpha levels, which alpha random of course does. it's all about exploring this really. Now that you understand these different categories, like what is an operator, what's an initializer, and so on, it's pretty easy to find new ones that look nice. So here we can have it spawn at different alpha levels. I like to vary it a lot because that does look more natural. Snowflakes aren't always the same density, of course. And now that we can see how fast they spawn, we can maybe change the emission rate a bit as well to be higher, so that we have a more dense snowfall going on here. Um, there is more advanced stuff that I can still go into. Um, I'm not sure how easy to understand that will be, but it's not really useful on this anyway, so I could go and add a force generator, but I think for a particle tutorial, this is already pretty fine. So I'll just go ahead and save this, and let's see how it looks like in SFM. So keep in mind that we're spawning the particle in a random sphere, which is at control point 0. This is something that I haven't really mentioned at all, but you don't have to worry about it either. Basically, by default, control point 0 will be the center of this sphere, as we have defined here, and so if you don't see your particle spawning, it's most likely because control point 0 is too far down. If we now go and switch back to SFM, create the particle like any normal particle, and position it higher up so that it gets some time to fade in and randomize its positioning and all that. You can see how it looks like. Now, we see two problems with it. It's way too little spawning and it's too dark. So now we could either just go back to the particle editor and fix the particle's problems, or we can use something called instancing, which you can access by right-clicking the particle and going to instance particle system, right-clicking it again, and then edit definition snowfall. And here we get a window identical to the particle system editor, except that we can now live see changes happening in SFM. It's also not editing the PCF file, this is editing a whole separate instance. So if we, for example, go ahead and change the emission rate to be higher, we can see this already happened in SFM. We don't have to even go back to it and move the player around or anything. So let's just change it to our likings from now on. So we can maybe decrease the radius a bit so that they spawn more concentrated. We can go ahead and remove the fade in because they may be too invisible. Make the color brighter a bit. So this is how I mostly do my particles after I create them. At first they may not be perfect, so that's when I go ahead and edit them a bit more. So maybe the speed is a little too fast, which is why they spread too much. It's a bit hard to tell. There. So now we move this up again to the correct position. And there we have it. We have a simple snow particle system which we can use however we want. Now of course I would have to put it down further and all that in order for it to actually look like it's in an area, but this is, as I said, just a pretty simple tutorial particle. I didn't really spend too much time refining it. So now you know how to create particles. We can go ahead and create a fire particle, because those are also fun to create. So let's go back to the particle editor tool. Now we are still inside our tutorial.pcf, so we don't actually have to create a new PCF file now, but just click create here, go to fire, and we have a new particle definition. So if you want, you can now go ahead and pause the tutorial, try creating it yourself, or you can just continue watching and I'll be making some fire for you guys. So, first off, we'll be picking a nice material. There's a lot of good fire textures inside TF2 and Half-Life 2. I like using Fire Particle 10 because it has this really realistic look to it. Now, of course, we first want the animated sprites renderer, a continuous emitter, and we actually have animation in this, obviously, so this is something new that it works perfectly fine already, as you can tell. It just looks weird because they're all inside each other, so we'll be doing some form of offsetting, but this already works pretty fine as it is. Of course we have to change a lot of stuff, but animation is the base thing that works, so that's good. So let's first off change the size of it to be a bit bigger. It of course depends if you just want a single point of a fire or if you want an entire surface lit on fire. Now, there's a checkbox here, animation fit lifetime, which decides it so that the lifetime changes the speed of the animation. Now, of course, the animation is so slow on its own already that I should maybe speed it up a bit. It really depends on what you're going for, of course. So, another thing that is special about this texture in specific, it has sequences, which are basically variations of the texture. As you can see here, there is multiple fire spurts that you can pick from, and I'll just let it randomly pick between 0 and 7, I guess. So this looks much more realistic already. If we want to further make it look random, we can have it spawn with a random rotation, so that it doesn't always look the exact same. We can also have it flipped randomly, so that the texture has even more variation in it. And that's the most basic stuff for the initializers, at least. We don't really want alpha transparency in this, because otherwise the flames look weird when they're separate. For operators, we first off want the alpha fade and decay as always. We shouldn't have it fade in because I think that looks weird. Actually, we can try, I guess. Actually, no, that's fine. We also want a movement basic that moves it up a bit. Not too much, but just a little, so that it actually looks like fire, you know? Yeah, I think that's good, and maybe have some randomized movement sideways as well, so it doesn't look so locked onto this plane. So let's give it some X and Y movement randomization. There we go, pretty simple fire particle that didn't take long at all, and it does look pretty nice, I must say. We can further change this if we so desire. Like, for example, have it spawn more, and all that. So I'll be saving this, see how it looks like in SFM. Now I do have to say that Snow Particle did not look as good as I wanted it to. I could, of course, go back to it, but I'm kinda lazy about it, you know. I already have a pretty good Snow Particle made by myself, so it's no problem. And let's see how this fire looks like now. Okay, yeah, that is pretty nice, I do have to say. I do like it a lot. Maybe I would actually go ahead and change it a bit more, because it does look too opaque. I think I'm spawning too much of it. I could try change the alpha value, see if it makes it look better. There's not much difference though, the additive blending of this is way too strong. Yeah, this is, yeah, the 2D you can see here it's much less white now, which is good. I I might go ahead and change the spawning ranges a bit more. That's fine, good. I'm happy with this. Oh yeah, of course, because bloom was enabled. It looked so strong. Okay, so this is our pretty basic fire now. It of course will look a little worse due to the 30 FPS of the recording, but I'm happy with it. So yeah, this is basic particle stuff. If you have any more questions, you can of course ask them, it's no problem. I could also go ahead and release this tutorial PCF file if you're curious. But I think that's it, so thank you very much for watching, hope you've learned something. Hope this was all pretty clear. I do apologize for all these cuts that I had to do here and there. I am pretty nervous about this sort of stuff. Anyway, bye.